This is Avi Networks. Welcome to the webinar on Elasticity, Portability, Intelligence from Smart Load Balancers. This is Ashish Shah. I'm the Senior Director of Product Management at Avi Networks. What we'll do today in the webinar is spend a few minutes on the slides giving you overview and introduction to what smart load balancing is and how it differs from your traditional monolithic appliances. We'll do a live interactive demo, and then we'll wrap up and take your questions. So at any time if you have questions, please ask them on the Q&A panel, and we will address them at the end. This webinar is being recorded, and the recording will be available in the next day or two on our website. All right, so let's get started. I'm sure some of the problems that I'm going to show you are familiar to you, right? If you're managing load balancers or in general any networking appliances, you have appliances to manage. You have to worry about capacity management, and on the other hand, you might have to over-provision yourself. It's expensive, it's inflexible, it's painful to troubleshoot. And then how do you take some of these to cloud environment or automate it? So these are the problems that we need to address by making the load balancers smart. And if you dig deeper, if you go to the next level, I'm sure you'll find this familiar with your own teams. Things are changing. Your architectures are changing at the application level. The architectures are changing at the infrastructure level. And that is causing different paces of change throughout your infrastructure teams. Your application teams are looking to implement a CI/CD kind of a model where they develop, test, roll out the application, and do this cycle continuously. This is a new model. They don't want to be opening up tickets to the ops and the networking team, but they want to do everything in an automated fashion on their own. So that is putting pressure on your ops and the networking team, where you need to be actually faster than what the app teams are doing on their own. You need to be able to deploy the infrastructure, monitor it, secure it, troubleshoot it, scale it out, all of this automatically so you can respond to and hopefully stay ahead of what your app teams are looking for. The days of ticket-based creation of VIPs or deploying load balancers or manual capacity management or waiting for 3 to 6 weeks to get the new capacity added, those are gone. And that is why we see a need for smart load balancing. Let's double click it one more level and look at the actual infrastructure level. So what I'm going to show you here is that the compute environments and the deployment environments have changed. How have they changed? You have going from your data center environment to a private cloud with or without SDN to a public cloud, usually a hybrid or multi-cloud environment. So that's a paradigm shift on how you are managing your infrastructure footprint. The second change that's happened is the actual deployment form factor of your applications, and as a result, all the application services. From the traditional bare metal to virtualized environments, of course, that happened over a decade ago, to more modern containerized and microservices environment that's happening now. And usually, again, you will see a mix of all of the above. There is no one clear answer for any one company or enterprise. While the compute environment, the infrastructure environment, the deployment environments are changing, the application network services have not kept up. Here is why I made the claim. If you look at your traditional load balancing or ADC solutions, such as the F5s and the Citrix and Scalers of the world, they're appliances. Hardware appliances, more recently, software appliances. They're still an appliance form factor, even in a virtual machine world, which means they may be okay for your on-prem environment or maybe private cloud, but you're stretching there, but clearly no automation, no flexibility, no elasticity, still monolithic application appliance management. So that's the concern with your traditional approach. On the public cloud side, of course, all the public cloud vendors, whether it's AWS, Azure, or Google, have their own load balancing solutions that's built into the cloud. However, there are two challenges with that. They're not full-featured. They're not enterprise-grade. If you're looking at moving some of your enterprise business-critical workloads to public cloud, Of course, you want the same level of feature sets and capabilities that you're used to on-prem. And second, the single environment. If you go to AWS, you're looking at ELB for AWS. In Azure, it's an app gateway, or Google, there's its own load balancer specific to one cloud. None of your applications environments are going to be a single cloud. They're going to be multi-cloud, multiple public clouds, and on-prem. So it's a multi-hybrid cloud environment. And you do not have a single solution that works across all of the above. You can argue, build your own, a DIY approach with open source. Sure, if you're Facebook and Google, you can do that. However, they are, first of all, the out-of-the-box solutions are not enterprise ready. So you need to put a lot of resources to develop additional features, maintain it, and then if people who have developed them move on, who's going to then take care of that or add additional features? All of these are the reasons why you need a next generation, a smart load balancing solution that works across all of the above: compute environments, deployment environments, application environments, cloud environments. All right, we've talked about the need for a smart load balancer. How do you define a smart load balancer? What is it? Well, let's start with what it is not. It's not your traditional monolithic appliances, physical or virtual. There is no proprietary hardware in the next generation smart load balancer. It's a software-only solution. And the myths around performance, etc., are long gone, and we'll talk about that. If you're building a smart load balancer, you build on a modern distributed architecture. That's how most of the, or I would say all of the next generation architectures are being built, whether it's SDN and networking, or how Google's or Facebook's or Microsoft's of the world build their own internal infrastructures. It's centralized brain, centralized control, distributed, scalable architecture. You need platform level capabilities such as automation, telemetry, and scalability. These are not features that you add to your product. These are platform capabilities that you build from the ground up so that the features, the load balancing capabilities, the security capabilities, maybe WAF capabilities, monitoring and application analytics capabilities, or other layer 4 to layer 7 services can be built upon a platform that's from the ground up modern, automated from beginning, has built-in telemetry, and has built-in scalability. That's a definition of a smart load balancer. And so that's what Avi sought out to do about over 5 years ago now. And we built keeping these fundamental principles in mind of what a next generation smart load balancer looks like. And that's why you will see that even if the traditional legacy load balancing vendors want to go ahead and build automation feature or REST API on top of the appliances or analytics as a byproduct, they are not smart because the architecture wasn't smart. It was built over a decade ago. So you have to be smart as a network and an application team to understand what is a fundamental platform capability versus what a bolted on feature is. All right, so what actually did we do? Let's go now double click into the actual architecture of what a smart load balancer looks like, one of which Avi has built. It's built, as I said earlier in my previous slide, on a modern distributed architecture. So if you look at a monolithic load balancer appliance, or in general any appliance, there is a control plane and a data plane. Typically, these load balancers are deployed as active standby pair. Again, a waste of resources. The first innovation that we did was decouple the control plane from data plane. And we centralized the control plane, distributed the data plane. We call the data plane service engines. The service engines are stateless. If you're familiar with the pet versus cattle analogy, these are cattle where individual service engines itself doesn't matter. You can kill one service engine, another one is spun up by the controller. The service engines themselves do not maintain the state, so they're just lightweight data plane only. That's why they're fast, they're super efficient, and they can be scaled out on any platform, whether it's bare metal, whether it's virtualized, whether it's containerized, or in public cloud as a VM or as a container. The beauty of this architecture is also centralized brain, the centralized controller, which not only becomes your orchestrator for this distributed fabric of service engines, it also uses a single REST API endpoint. It's a centralized policy repository. It's the automation brain behind it. And so from operations point of view, you are not talking to individual load balancers. And that's a key difference between an appliance, a virtual appliance that is, and this architecture. You don't log into individual service engines. You get as a service experience. You send an REST API call to controller, say, I need this VIP to be placed. The controller then decides which tenant this is part of, what is the application affinity, what is the security policy, what is the performance of my underlying infrastructure service engines, and decides where to place the VIP, where to place the virtual service, whether it spins up another service engine or uses one of the existing ones if there's enough capacity. That's the decision of the controller. You are not in the business of capacity management. The controller is. You are in the business of defining centralized policies that AVI controller will automatically adhere to. The AVI controller will also collect the analytics. So the service engines sit in a very strategic role that many of the other vendors have forgotten. Every transaction, all data traffic goes through the load balancers. And as a result, they have tremendous amount of visibility that you can leverage. And that's what we do. The service engines collect those telemetry data, push it up to the controller. Controller not only gives you pretty dashboards that you can see on an AVI dashboard or connect to Grafana or Zabbix or whatever your tools may be, but the AVI controller uses that information for automated policy-based changes. For example, let's say I've deployed 10 service engines, and one of them has a few VIPs that certainly need high performance. AVI controller will spin up another service engine, move a few of those VIPs to the newly spun up service engines in a completely non-disruptive and transparent manner, and suddenly scale out to capacity. And it keeps doing that within the constraints of the policies that you've defined. That is the beauty of automated, analytics-driven architecture. The other thing the controller does is not only does a southbound automation, what I just explained, but northbound automation, being able to communicate and automatically talk to other orchestration tools, be it vCenter or VRO, VRA built on top of that, or OpenStack or EC2 APIs or Azure APIs or Kubernetes and OpenShift or building an Ansible playbook on top of REST APIs. These are available from day one. These are product capabilities. These are not bolted on features. As a result, it's completely plug and play. It's highly automatable and programmable. And the final piece is around performance. Again, the hardware vendors have propagated the myth that you need custom ASICs for high performance. Well, that's absolutely not the case. If the largest of the hyperscale vendors can deploy their workloads on x86, why can't you? And as a matter of fact, each individual service engine of one vCPU, so smallest ever service engine, can do 5 gig of raw throughput, 1.5 gig of encrypted SSL throughput, 2,500 SSL TPS. We actually have demonstrated, and it's on our website, a 1 million SSL TPS in a public cloud for a single whip. You can see the demo today. As a fabric, we can scale up to terabits of capacity and millions or tens of millions of SSL TPS. So performance, a non-issue. All right. With all that background, let's actually see some of this in action. So let's see a few demo scenarios, and then we'll come back and wrap up. So what you see here, actually, I'm going to log out. I'm going to log out and show you how I log into my dashboard. So this AVI UI is built on top of REST APIs. So this is just an HTML version of the REST API. And of course, you can build custom dashboards, custom UI, as well as Ansible, Terraform, Swagger, all of those things are built in. So let me log in as Ashish. And when I log in, I automatically get placed into my tenant, the tenant that I have access to. So the system itself has multiple different tenants, over a dozen tenants. And when I log in, as soon as I am able to log in, I get placed into the demo tenant. Let me see if I type the password in correctly. No, let's wait for that. And you'll see that, well, this is the beauty of the live demos. Oh, there you go. All right. So, looks like we have a couple of services down. So that's actually a good segue into my next point, which is around application health score. So first of all, I got logged into a demo tenant. I have access to a few other tenants, but not others. There are over a dozen tenants on the system. The first thing you'll see is an application dashboard. So it's not like your traditional load balancers that shows you your WIP is up or down. We actually give you a comprehensive health score. They're color coded by green, yellow, orange, or red, depending how they're doing. And the health score itself consists of 4 different components. So for example, for this demo virtual service, there's a performance score of 95, which is great, which is a measure of the throughput, the latency, any errors that might be going on at the HTTP, HTTPS level. That's a performance score. That's pretty good. However, there are a few penalties that you can see here. The resource penalty is a measure of how heavily utilized your underlying resources are. Now, here is the smartness. It's not just the load balancer resources, it's also the application resources. So the controller actually logs into vCenter or OpenStack or EC2 or whatever the environment may be, understands how heavily utilized the application VMs are in terms of CPU, memory, disk, etc. And based on that, and based on the load balancing VMs, similar metrics, gives you a comprehensive resource penalty score. This is smartness, where it's giving you a holistic view of how my application is doing. And this is a measure of, well, if I increase additional traffic, I might not be able to keep up because my resources are saturated. And on that, you can actually scale out automatically. Similarly, there is a concept of an anomaly penalty, which is a measure of any abnormal spikes or drops or anything that's unusual. We automatically baseline the performance and call out these anomalies dynamically. And finally, there is a security penalty, which is a measure of SSL configuration, any weak ciphers that you have configured, or an SSL certificate is about to expire. It gives you a ding so that you can take immediate action. Or is it a DDoS attack that might be going on? All of this goes into a security penalty, and we'll show you a breakdown what I'm talking about in the next dashboard. I'll also show you a different view of this WIP. The same WIP, I'll show you a more infrastructure-centric view, where this virtual service is running on this load balancer. So far, I have not even shown you the service engines because they're automatically managed by the RV controller. But in this view, you will see that it's running on this particular service engine. There are 3 pools, so content switching, of course. What are the backend servers that it's load balancing? So in this case, you will see that this pool has 2 servers. One is up, the other has been disabled by this user. And sometimes you say, why only have 1 server? What's happened? Something wrong? Well, it tells you in this case it's disabled. In this case, it's not disabled. It's down because ARP is unresolved. So it's a networking issue, right? So you're able to get individual troubleshooting insight even without double clicking too much. It gives you at the WIP level, at the application level, where the problem might lie. This is where smartness comes in. This is where the architecture comes in, where with a centralized dashboard, by integrating with the rest of the ecosystem that your application deploys in, we're able to give you this level of insight. It's not just an appliance, just not a load balancer. It's a smart load balancer. All right, now let's go further in the demo and double click on this WIP itself. So the first thing you see is for this virtual service, you see an end-to-end timing dashboard. And this is displayed by default for 6 hours, but you can change it to week, month, year, whatever you want it to. It's keeping the data around what are the latency breakdowns at every stage of the traffic. As I said earlier, this load balancer sit at a very strategic location. So without any agents, this is important. Without any agents, we're able to get you what the latency breakdown is at every stage of the transaction, whether the client RTT time, 70 milliseconds, server RTT time, which is the latency between the load balancer and the backend server. It's 1 millisecond. That's pretty good. That's no networking issue there. The application response time is 40 milliseconds. That's the delta between the application establishing the TCP connection and it's receiving the HTTP request and sending out the HTTP response. So how long it is taking to process the application request. And then how long does it take on the wire between the first and the last byte of the packet? This is a measure of the bandwidth. Now, this is an average. You'll actually see that there is a spike here earlier this morning at 8 a.m. Pacific, and we have called out with an anomaly. And you notice that, first of all, color-coded latency information tells you that it's the application latency that has shot up. So otherwise, the app latency was in the 33, 34 millisecond range, but in this time, it has gone up to 70 milliseconds. Rest of the metrics haven't changed much. You're still within the same range as you had before. So the problem in this case is not the network, it's the app. This is a very, very powerful dashboard. Most of our customers call it mean time to innocence dashboard, especially the networking folks, because why? Networking team always gets blamed for any performance issues. This dashboard tells you if there is a problem, and if so, where is it? Is it on the WAN? Is it on the local network? Is it on the application, or is a bandwidth an issue? Right there, without clicking, you get that level of information. Extremely powerful. These are built-in features, by the way. We don't charge for, as I said, analytics is not a feature for us. This is a platform capability. It's important. Of course, you have on this one, you have throughput, the connection rate, the request rate, everything that you expect from a standard load balance to have, you have that. But this is the smartness that's built in. Let's go now from a 10,000-foot view to a needle in the haystack kind of analytics. What you see here is a Google-like or a Splunk-like dashboard for your application traffic. Without any agents, without adding additional tools, we have every log that is going through the load balancer on this screen. By default, we show you what we call significant logs, which means where we see that there is a problem, we automatically surface it. If you wanted all the logs, you just click on this and the controller just pulls those logs from the service engines. Let's see what an individual log looks like. So let's open this up. So this particular transaction, it's an individual transaction level information here. This transaction came from this IP address and port, location is Singapore, and if you have an internal traffic, of course you can create your custom locations and say this is coming from San Francisco office, this is a Boston office, or it's a London office, or a Tokyo office. You can do that. What type of user device it's coming from. What is this transaction's WAN latency, local network latency, app latency? Why was this transaction mapped as significant? Because it has a high app response time. 96 milliseconds is high. We saw earlier that the averages should be around 34 milliseconds. And also, it also took much longer to respond after the last byte was sent. So basically, overall latency from the server side seems to be high. What was the URI that this request was for? Which backend server handled that? All of the information is available. You also get full HTTP headers, by the way, what came in and what was forwarded, including X forwarded for, etc. Right? Everything is for a transaction. Now, how do you use it? Well, you can use it in a variety of ways. If you are a network admin, you are interested in finding out, if I just scroll down here, why some of the latencies are high. If you are, let's say, security admin, and you want to find out, let's do some security analysis and say, oh, SSL, what are the different SSL profiles this is coming from? Okay, I see no data, which means some transactions didn't complete. Primarily TSL 1.2, excellent. I still have a couple of TLS 1 and 1.1s. Let's see who it's coming from. Let's reach out to those users and say we don't support it, or you want to let's say deprecate it. A couple of SSL v3s, most likely they actually didn't even complete because we don't support SSL v3. It's an old protocol that is vulnerable to various attacks. If I actually click on that, you will see that we did not even complete the transaction because a handshake failed. Wrong version number. See that where it's coming from, which IP address is coming from. So you can go back to those users or clients if it's a local internal application saying, please upgrade your browser. We don't support this, etc. If you are an application admin and you want to find out what am I generating? 200 is great. A couple of bad requests, I'll look at that. But there are 404s. 404s are never good. That means something is broken on my server. Let's see what's going on. So visually, I can see there is one PNG file, but let's just rule that out. So let's go ahead and make sure what URI paths are generating 404s. Okay, there are a bunch of one-offs, but there is primarily a logo.png file. Let's filter the logs further and see which backend server. is generating this. So let's go ahead and look at the load balancer analytics and look at which IP address on the backend side. Only one. Only one out of the 4 servers that I'm load balancing has this file missing. This can be done by the network team to tell the app team it's not the network, it's the app, and here is the problem. Or this can be done self-service by your application team. You don't even need to be on the ticket receiving end. You just say, Mr. Application or line of business team, here is a dashboard, fully multi-tenant through RBAC. You cannot step on anybody else's app, but please troubleshoot your own application before opening up any ticket. Extremely powerful. Similarly, if you are an app admin and you want to find out who's using my application, what kind of browsers is the traffic coming from, because as a part of the CI/CD chain, I want to test out the most commonly used browsers before I generate the next version, before I roll out the next version of the release. Well, it tells you this is the breakdown of the browsers or the breakdown of the devices and so on. Very, very powerful for networking and apps teams, extremely powerful for the app teams as well, complete self-service. And the app teams want to automate the whole WIP provisioning as part of the CI/CD. The Swagger documentation is built in. So for every object, everything is API driven. There's nothing in the object that you can't do with REST API. For that object, what are the corresponding CLIs? How do you use those CLIs? What are the corresponding HTTP methods? What are some of the examples? Payload. What are the payload? What are the individual fields? Complete REST API and object documentation is available on the controller itself. And of course, we have a GitHub where all of this Python and Terraform and Ansible playbooks, they're all available there. Again, a definition of a smart load balancer, where these are not bolted on features that are built in from the ground up. All right, I will do one last demo, and then we'll wrap up with a few more use cases and Q&A. So if I go back to this particular WIP, I'm going to actually show you 2 things. I told you about health score earlier, right? So here it tells you this WIP has a very low health score. And it consists of 4 different things. So it gives you a visual representation of, okay, performance is low. All right, we'll take care of that. There's a security score that's also low. Let's see what's breaking the security score now. So it's a combination of SSL score is low and a DDoS attack that's going on. So it actually tells you what's going on, right? So let's go to the security tab and look at what's going on. So first of all, at the individual virtual service level, we'll give you a score on your SSL profile. So PFS is supported, check. It's at least 1.0, check. Weakest algorithms are strong enough, check. Well, the score is dinged because it doesn't have a trusted certificate and it doesn't have HSTS enabled. Both are dinging the score. Similarly, if the certificate's about to expire, then it'll ding the score as it goes closer to the expiry. It goes from 5 to 4 to 3 to 2, so it can immediately take action. We can even do better than that. We have ability to automatically renew the SSL certificate by integrating with the PKI servers. So it's not just visibility, we can actually automate the whole process. That's a smart load balancer. Also, of course, gives you visibility into certificates, PFS, non-PFS, TLS version breakdowns. And on the right-hand side, it tells you a DDoS attack that might be going on. So combination of L4 and L7 attacks. And if I double click on that, it actually tells you what the different attack types are, what client IPs it's coming from, what AS is. You can block it with a single click or equivalent with a REST API call. All of that is available right here at your fingertips. So it's extremely, again, powerful from security point of view as well. All right, with that, let's go ahead and, okay, so this came up. So this tells you it has a HTTP timeout attack, a SIM thread attack, and an error attack that's going on. All right. With that, I'm sure you have questions. So as I wrap up over the next couple of slides, we will get to the questions answered. But before I do that, let me address some of the common questions. What about features? I use iRules in F5. Of course, those are built-in policy capabilities. In fact, 90% of the iRules are handled directly through what we call native policies. And for the rest 10%, we have something called DataScript, a newer, more modern programming language. Of course, we do L7, L4, SSL, content switching, caching, auto scaling, unique to Avi. The public cloud vendors give you, but Avi gives you auto scaling of applications and auto scaling of load balancers in any environment. WAF is built in. It's not a separate SKU. It's all of the above. All these features are included in the base product. DDoS protection and mitigation, ACLs. In a container environment, like OpenShift or Kubernetes, we also do distributed firewalls, so microsegmentation. Analytics. You saw some of the analytics that we have only seen maybe 20% of what we have. There are way more analytics that's available. It does about 80% of what your APM and NPM tools do. Security insights, we took a look at that. And all of this is built on a fully multi-tenant, centralized, managed, REST API-driven architecture. All right, use cases. Where do customers use Avi? So a common use case for us is as your legacy load balancer up for a refresh, Avi can replace those legacy load balancers for equivalent or a better performance with the next generation modern smart architecture at usually half the price of your X5 or Citrix, while giving you centralized management, analytics, and programmability on top of those cost savings. We have customers in public cloud. So for example, you might have seen a recent press release from Avi and Microsoft and Adobe, where we helped Adobe go in production in Azure with Avi's load balancing solution. And so that, again, we have customers running in AWS, we have customers running in Google Public Cloud and SoftLayer and so on. And what Avi gives you is an enterprise-grade feature set that you're used to on-prem with as-a-service experience of your cloud. So without taking away the ELB or the app gateway experience that you need, so you get the same CloudFormation templates or ARM templates or Elastic auto-scaling experience without compromising the features at a price point that is equivalent to or usually lower than what you pay to public cloud vendors. So it's a win-win-win situation in public cloud. Similarly, private cloud, we have customers using us in OpenStack or VMware-based environment. You might have seen a press release last year, an article from EBSCO, a US East Coast-based company where they're using us in an OpenStack environment. A web application firewall. We've done a recent case study with Swisslos, a Switzerland-based lottery company, where they replaced the legacy WAF solutions with Avi. Why? Smarter architecture, analytics, automation, centralized management. And then, of course, we have customers using us in global server load balancing, DNS and IPAM use cases, as well as more cutting-edge service mesh. We have production deployments at banks using us in OpenShift and Kubernetes environment today. Why? Same. It's a smart architecture, enterprise-grade features, built-in scalability. So let me summarize. Why Avi? It's a smarter next generation, built from ground up architecture for your next generation environment, giving you 50% plus cost savings in your traditional environment and public cloud environment, future-proofing you for whatever deployment you're going towards, much faster troubleshooting, much faster provisioning. All right, that brings us to Q&A section of our webinar. By the way, if you have any questions, here is a URL. Reach out to us. We'll schedule a custom demo for you. In the meantime, looks like there are a few questions on the Q&A panel. The first question is, how does the Avi load balancer know the application with status? So, excellent question. So the controller is the brain of the system. So the controller is taking into account the performance, which means the throughput, the latency, any errors, etc., that it knows because it's measuring that. But also, it is communicating with vCenter or AWS or whichever environment you are in to understand the health of those VMs on which the application is running. So the combination of inline health monitoring that other load balancers do as well, but inline health monitoring, latency, which we measure, the throughput, the error rate, as well as the metrics on the backend systems where the application is running, we're able to give you a comprehensive health score. All right. The next question is, why would the load balancer want to intercept the application logs? No, actually, it's not intercepting application logs. you see a proxy, a load balancer is a full proxy, which means it's terminating TCP, terminating HTTP, and terminating SSL. As part of that, it is logging the header information. It is logging the information about the clients, where the client is coming from. It's all available in headers. We are not, in this screen that I showed you, we are not looking inside the application payload. We have the ability to, if you want us to, look at specific fields in the application header. But what I showed you was just looking at the HTTP, TCP, and SSL headers. And that gives you tremendous insight. Question, will this integrate with F5 GTM environment? Yes, absolutely. So first of all, we have our own GSLB, but, and it's not a separate appliance, which means the same service engines can run both LTM equivalent and a GTM equivalent. It's not a separate appliance. It's a service. However, we do have customers who say, well, and they're migrating from F5 or Citrix to Avi, and they say, can we do a step-by-step migration where, in some cases, I have F5 GTM. I want to move the LTM to Avi first while maintaining F5 GTM, and at some point when everything is Avi, I'll move the GSLB to Avi. Yes, we actually have that. We have published documentation as to how to integrate with third-party GTMs or global load balancers. Absolutely. Great questions. Keep the questions coming. More questions. What type of telemetry data do the load balancers send to the controller, and how often? Well, part of the questions I answered, but it's a combination of logs and metrics. Logs are coming from the headers, TCP, HTTP, SSL headers, as well as application headers if you choose us to do so. The metrics are around the latency information, how long it took for the TCP connection to set up, or how long it took for the HTTP response to come back. So combination of the logs and metrics are sent to the controller. There are configurable knobs. The significant logs are sent by default. The non-significant logs are pulled on demand. You can change the frequency based on your scale, etc., with easy knobs. Next question: which SDN environments do you support? All of the above. How does it work? So let me go through the details. We work with Cisco ACI, VMware NSX, Juniper Contrail, as well as Nuage VSP. We work with all the vendors. We have customers running in all of the above environments. And the way it works is actually it's easier in the sense that in an SDN environment, you have a centralized controller and a distributed L3 fabric. Avi is a centralized controller, distributed L4 to L7 fabric. It's very similar architecturally. So the Avi controller communicates with the SDN controller for exchanging policy information, or exchanging or plumbing in the networks in the right port groups, for example, or in case of NSX, automatically configuring the distributed firewall policies. In case of Juniper Contrail, automatically doing ECMP. In case of ACI, doing automatic service graph, etc. So depending on the SDN controller you work with, we integrate with all of them, and the details are specific to each of them. All right, I have one more questions right now, but if you have more, please keep them coming. The next question is, how do you size and license your environment? Excellent question. You're thinking like a smart load balancer now, because it's not an appliance. So how do you size it, right? It's truly performance-based. As I said earlier, each vCPU worth of service engine can do 5 gig of raw throughput, 1.5 gig of encrypted SSL throughput, 2,500 SSL TPS. Well, that's your starting point. You understand what your needs are in terms of performance. You size it to the number of CPU cores that you need. You account for HA. You do not have to do a legacy active standby HA. We support active HA, which means you can have, let's say, 20 or 30% extra for HA. And then one of them goes down, you're down by 10% or 1%, and not 50%. And that's how you size it. And that then translates into licensing. Our licensing is by compute capacity of the underlying load balancer service engines. No charge for controller, no charge for analytics, no extra charge for WAF. So 24/7 support is included. So it's a subscription model. There is no feature version lock-in like some of the legacy vendors that you can only upgrade from version 11 to 13, for example. None of that. As long as subscription is active, all new features, all new versions are available, and it's based on number of CPUs that you use for your service engines. All right, great. While I was talking, more questions came about. How does Avi Load Balancer maintain stickiness on the client and the server side for different protocols? Again, we support your normal persistence. For example, in HTTP, you have application cookie persistence or HTTP cookie persistence, source IP persistence. All of those are supported, and it's supported for most common protocols. All right, this is great set of questions. If there are no more questions, I'll wait for another minute or two, but if there are no more questions, well, thank you very much for attending the webinar. If you have further questions, please reach out to us. Here is the URL. You can also reach out to sales@avinetworks.com. And if you're interested in more information, please check out our smart versus legacy load balancer videos. It's actually a very interesting and a very funny series of video, which gives you in less than 90 seconds how the basic premise of smart versus legacy load balancers. Oh, there's one more question. How do I get full training? Excellent. We have most of our content available on kb.avinetworks.com. So while I'm showing you here, if you go to kb.avinetworks.com, this is where all our content is available. Start there. Start on our webinars and video pages. We have gone through various basics of Avi. And then if you're interested in custom training, reach out to us. We can provide you a pointer to that. All right. With that, again, thank you very much for your time and spending this 45 minutes with us. We hope you will reach out for more questions and have a great rest of the day. Thank you.